6.1F is on solving simple quadratic equations. So we haven't really talked about quadratic equations yet, but we will spend the majority of semester 2 talking about them. So a quadratic equation is an equation that's got x squared in it. So we've solved for x a lot, we've solved for y a lot this year, but we're going to figure out how we could solve for x when we've got this quadratic in there. So remember, when we're solving, the key to solving is using those inverse operations. So the inverse of addition is subtraction. The inverse of multiplying is dividing. Also remember that our square root is the opposite of squaring. So something we haven't talked about a lot, but the square root of 9 actually has two possibilities. So the square root of 9 could be rewritten as a square root of 3 squared, which would just be 3. But another way you could multiply to get 9 would be a negative 3 times a negative 3, right? Because since there's two negatives, our negatives would cancel each other out. So the square root of negative 3 squared would be negative 3. So the square root of 9 is actually equal to a positive 3 or a negative 3, and we write that as plus or minus 3. So we're going to use that in order to solve these quadratics. So what if we can we take the square root of all numbers? No, we actually can't. And so when we're looking at something like the square root of negative 4, we can't find that in our real number system. So when we have something like that, we would say we have no real solutions, because again, we're working in the real number system and we are not equipped to solve that at this point in time. So that's all the groundwork you need. In order to solve our radical equations, we're going to do three things. First off, we're going to isolate x squared. So you're going to get x squared all by itself. Second off, you're going to take the square root. So take the square root of both sides of your equation. Okay, remember, it has to be both sides of your equation. And then last but not least, you're going to simplify if possible. So isolate, take the square root, and then simplify if possible. So let's go ahead and practice. Remember to flip back to these slides to review if you need to. So letter A, we have x squared minus 36 equals 0. So our first step is going to be to isolate x squared. Well, I'm going to use the inverse of subtracting 36, which would be adding 36. Right? So these would cancel out. That's what I want. That's why we use our inverse operations, so we can rearrange things. So we find that x squared is equal to 36. So that's my first step. My second step is to take the square root of both sides. So I'm going to take the square root of x squared. These would just cancel out, so I'd be left with x. And then the square root of 36. I can simplify this, and so that would be 6 times 6, which is just 6. But remember, positive 6 times positive 6 could be 36, but negative 6 times negative 6 could also be 36. So we actually have two answers. X could be a positive 6 or a negative 6, and we write that as x equals plus or minus 6. So we could plug a positive 6 into this equation and we get 0, or we could plug a negative 6 into this equation and we would get 0. Let's go ahead and look at letter B. We're going to do the same steps. So let's just start off and isolate our x squared. We're going to add 98 to both sides. So 2 times x squared equals 98. Well, let's get that 2 out of there. We can divide by 2 on both sides. So we find that x squared equals 98 divided by 2 would be 49. And now our second step would be to take the square root of both sides. Well, the square root of x squared is always going to be x. The square root of 49 would be 7, but it could be a positive 7 or a negative 7. So x plus or minus 7 is our final answer. Let's look at a couple more. It'd be a good idea to pause and see if you can solve this for yourself. Letter C, 9 times x squared minus 25. Well, we could add 25 on both sides. So 9 times x squared equals 25. Well, then we could divide by 9 to get x squared, or to isolate x squared. So x squared equals 25 divided by 9. And now we could take the square root. Well, the square root of x squared, again, is always going to be x. Square root of 25 divided by 9. Remember, we could pull that apart, and we could figure out, well, what's the square root of 25? What's the square root of 9? The square root of 25 is 5. The square root of 9 is 3. So x equals plus or minus 5 divided by 3. Looking at letter D, 2 times x squared plus 6 equals 6. Well, let's start by isolating x squared. So we'd get 2x squared equals 6 minus 6 would just be 0. So 2 times x squared equals 0. Divide by 2 on both sides to isolate x squared. We get x squared equals 0 divided by 2 is just 0. We could take the square root. The square root of x squared is just x. The square root of 0 is just 0. And there's really no such thing as plus or minus 0. So x is just equal to 0. So notice how on letter C we had two solutions. X could be a positive 5/3 or x could be a negative 5/3. But on letter D we just have this one solution of 0. 0 is the only value that we could plug in order to make that equation true. And that's what we're doing when we're looking for x. We're trying to figure out the values we could plug in to make this equation true. Well, x squared, we could subtract 4x on both sides. So we get x squared equals 0 minus 4 would just be negative 4. Take the square root of both sides. Well, the square root of x squared is x, but we can't take the square root of negative 4, right? We don't have anything, or we don't know what times what could give us a negative, right? 2 times 2 would be a positive 4. Well, that's not what we want. Negative 2 times negative 2 would be a positive 4. That's not what we want. And 2 times negative 2 or negative 2 times 2 aren't the same number. So there's no way we can take a number and multiply it by itself to get negative 4 in the real number system. So since anytime you see that negative underneath your radical, that should be a big red flashing light, and you should immediately think, well, the answer is no real solutions. No real solutions. Looking at letter F, well, we could subtract 5 from both sides. So we'd get 2x squared equals 90. Well, we could divide by 2 on both sides. So x squared equals 45. And then we're going to take the square root. Well, the square root of x squared is x. The square root of 45, here we actually have to simplify. We could write this as 9 times 5. In other words, 3 times 3 times 5. So we would have the square root of 3 squared is 3. The square root of 5 we can't simplify, so that's stuck inside our radical. And then always remember your plus or minus. So x equals plus or minus 3 times the square root of 5. And remember, if you can simplify, you have to, so that's why we had to simplify the square root of 45. Just a couple more examples to look at. It'd be a good idea to pause and try them out if you haven't done that for yourself yet. When we're looking at x squared plus 8 equals 120, well, we could subtract 8 from both sides. So we get x squared equals 112. Then if we're taking the square root, well, square root of x squared is just x. We don't know the square root of 112 because it's not a perfect square. So again, we would have to simplify this. Well, 112 is 2 times 56. 56 is 2 times, pardon me, 56 we could write as 8 times 7. Well, 8 is 2 times 4, and 4 is 2 times 2. So let's see what we have. Here's a group of 2, here's a group of 2, and then 7 all by itself. So we really have x equals plus or minus, don't forget your plus or minus, 2 squared, the square root of 2 squared, times 2 squared, times 7. And when we simplify that, x equals plus or minus, 2 from here comes out, 2 from here comes out, so 4 times the square root of 7. That's what you should get when you simplify for letter G. Last but not least, letter H, we could divide by 3 on both sides. Well, we can't take 7 divided by 3 because we wouldn't get a nice number. So we get x equals, well, square root of 7 divided by the square root of 3. We could pull that apart into the square root of 7 divided by the square root of 3. We can't simplify either of those, but we do need to rationalize our denominator. So this would really be the square root of 21 divided by 3 times the square root of 3 times the square root of 3 is just 3. Can't simplify anything else because we rationalized our denominator, and we can't simplify the square root of 21. So x equals plus or minus the square root of 21 divided by 3. And that is our final answer. So when we're solving our quadratic equations, we have those 3 steps. Remember, you start with isolating x squared, and you still need to have your final answer, and